In solving equations that involving surds, we still need to apply these 4 rules of surd which have been discussed in chapter 1. Multiplication, division, addition and subtraction between surds, and also multiplication between surd expression and its conjugate. On top of that, all of these rules only applicable if and only if A and B are positive real numbers. In example 3, we have 3 different patterns of equation involving surds with 3 different approaches. So we're going to discuss the best approach if we have 1 surd, 2 surd, and 3 surds in one equation. In the first example, we have 1 surd in these equations. So we're going to isolate the surd on the left hand side by bringing x to the other side. To eliminate the surd on the left hand side, we're going to square in both sides this equation. As you can see, on the left hand side we have 1 term with surd, but on the right hand side we have 2 terms. So they have different way in squaring both sides. On the left hand side, the surd sign will gone, so we're going to have 3x plus 1 only. But on the right hand side, we need to expand the bracket x minus 1 multiply x minus 1 since it have 2 terms. So expanding the bracket, we're going to get x squared minus 2x plus 1. So this is a quadratic form. Then we're going to express this equation into standard form by bringing all the terms on the right hand side to the left hand side. Plus 2x plus 1 minus 1 equals to 0. So here we have negative x squared plus 5x equals to 0. I wanted to make sure that the a is positive here. So rearranging this expression, then I'm going to factor out x to factorize this quadratic equation completely. So I have 2 solutions of x. The first one is 0, then the second one is 5. Remember, since we have 2 possible answers for x, we need to check which value of x satisfies the original equation by do the checking process. Okay, so now start with x equals to 0. We substitute x0 into the original equation. On the left hand side, I have 3 multiplied with 0 plus 1 square root. Then simplifying this, I'm going to get 1. And on the right hand side, I replace x with 0. Minus 1 equals to negative 1. Since both answers are not equivalent, then we reject x equals to 0. Then check the values of x when it is 5, whether it satisfies the original equation or not. So on the left hand side, I replace x with 5 plus 1 and then evaluate this answer using calculator. I'm going to get 4. Then on the right hand side, I plug in x equals to 5 minus 1. I'm going to get 4 as well. Since both sides is equivalent, then we accept x equals to 5 as the solution for this example. In example 3b, we have 2 surds in one equation. What we will do if you have 2 surds, put 1 surd at one side, then squaring both sides to eliminate the surd. But wait, to make things easy, let's replace x minus 2 with a and x plus 3 with b. So proceed with squaring both sides to eliminate the surd on the left. But since we have 2 terms on the right hand side, we're going to expand this bracket. Then by expanding this bracket, I'm going to have 25 minus 10 Surd B plus B. Again, isolate Surd at one side. Then bring A to the right hand side. Then put back the substitution for A and B. So 10 Surd x plus 3 and 25 minus x minus 2 plus x plus 3. Simplify the right hand side. I'm going to get 30. Then on the left hand side is 10 Surd x plus 3. Then bring 10 to the right hand side. I'm going to have Surd x plus 3 equals to 3. Then again, to eliminate the surd sign, we're going to square in both sides. Then only 3x plus 3 left, and on the right hand side it becomes 9. Then for this example, my value of x is 6. So we end up with one solution. Then not necessary for us to check whether this solution satisfies original equation or not. Is it necessary for us to make sure one surd at one side? The answer is no. So this is the alternative method from the previous example. We can still proceed with squaring both sides even though the both surds were placed at one side. Use the substitution A and B to replace x minus 2 and x plus 3. Then the square of these two terms will be A plus 2 Surd AB plus B. How you get this expansion is from expanding the bracket Surd A plus Surd B with itself. Surd A multiply with Surd A, you're going to get A. Surd A multiply with Surd B, you're going to get Surd AB. Surd B multiply with Surd A, again plus Surd AB. Surd B multiply Surd B, you're going to get plus B. So simplifying this, you're going to get A plus 2 Surd AB plus B. So this is what we got on the left hand side. And then 25 is where you squaring the number 5. Okay, and then after you get this complete expansion, you just replace back A and B with x minus 2 and x plus 3. But there is still one single surd on the left hand side. So bring the other term that has no surd sign to the right hand side. Then our right hand side will become 24 minus 2x. And then bring as well number 2 to the right hand side. So it becomes 12 minus x. Then we have a single surd on the left hand side. To eliminate the sign, we need to squaring both sides again. So this single surd sign will gone and become x minus 2 multiply with x plus 3. On the right hand side, we're going to square 12 minus x. Then the calculation is 12 minus x multiplied with 12 minus x. Expanding this both bracket, you're going to get x squared plus x minus 6 equal to 144 minus 24x plus x squared. Simplifying this, you can see that we can cancel x squared on the both sides. Then bring negative 24x to the left hand side, you're going to get 25x. Then bring negative 6 to the right hand side, you're going to get 150. So here, by bringing 25 to the right hand side, you're going to get the x value is 6, like what we got in the previous example. Student, in example 3c, we have 3 surds. So, do we need to rearrange the surd? The answer is no. Just proceed with squaring both sides method. And then use substitution A, B and C. A is to replace 3x minus 5, B for x plus 2, and C for x minus 6. If you square 1/3 on the right hand side here, the third sign will gone. But if you have two terms with 2/3, like on our left side now, we need to expand this bracket. Then you're going to get A minus 2 third AB plus B equals to C. Then isolate the single third on the left hand side and bring A and B to the right hand side. Then replace back your A and B and C with 3x minus 5, x plus 2, and x minus 6. Okay, simplifying the right hand side, we're going to get negative 3x minus 3. Then just copy back what we have on the left hand side. Okay, and then to eliminate the third sign, we need to squaring the both sides again. On the left hand side, if you square negative 2, you're going to get 4. Then if you square the third sign, the single third sign here, the sign will gone. So you just have 3x minus 5 and x plus 2 without the third sign. Then the right hand side, going to expand this bracket. Okay, so expanding the bracket, you're going to get 3x squared plus x minus 10 equals to 9x squared plus 18x plus 9. Then multiply this bracket with 4, you're going to get 12x squared plus 4x minus 40 equals to, copy again this part. Then this is a quadratic equation. Bring all the terms to the left hand side. Then simplifying, you're going to get 3x squared minus 14x minus 49 equals to 0. Then factorize completely the function. You're going to get 3x plus 7 multiply with x minus 7 equals to 0. So there is two possible answers. The first one is negative 7 over 3. Then the second one is 7. Okay, since we have two possible answers, we need to check whether both answer or either one will satisfy the original equations. So start with the first root, which is negative 7 over 3. Check to the both sides. Replace x with negative 7 over 3. Minus negative 7 over 3 plus 2. Okay, simplifying this, you're going to get third negative 12 minus third negative 25 over 3. But remember, square root of a negative number is not real number. So there is no solution for the left part. On the right hand side, replace x with negative 7 over 3 minus 6 square root. Okay, again, this is a square root of a negative number. So there is no solution as well on the right part. So we reject this root because both part has no solution. Okay, so let's check for another root, which is 7. Replace x with 7 on the left hand side. So 3 times 7 minus 5. Surd minus 7 plus 2. Then simplifying this, we're going to get 1. Then on the right hand side is 7 minus 6 square root. Then simplifying this, you get 1 as well. So since both part is equivalent, then we accept x equals to 7 as the solution for example 3C. Okay guys, so we are at the end of lecture 1. To test your understanding in solving equation involving indices and surd, please do these exercises and refer your lecturer to check your working. Thank you.